Okay, folks, I think we'll get underway here. We will have a few topics to discuss, and we'll take questions and discussion points in the second half, but it's my pleasure to speak with you this morning, afternoon, or evening. Thank you for spending the time. I'm Bob Noseworthy, and I'll be joined with Griffin Leclerc coming up, and we're just going to touch on a few updates since our December update, and I'm hoping that this will be a continuing dialogue throughout this year and perhaps the years ahead if this remains an effective means of fielding your feedback and also providing you our updates on our various activities here at the University of New Hampshire's Interoperability Lab. So some of you I recognize from the attendees, some unfortunately I do not. So just a very brief reminder of what the UNH-IOL is about. We are in our, 34th year of existence. We're a nonprofit neutral test house focused mostly around data communications, storage technologies here in Durham, New Hampshire, about an hour north of Boston. And specifically for the groups we're addressing today, it's around our Ethernet, single pair Ethernet, time-sensitive networking spaces with which we've been involved with for the past 17 plus years, various organizations, Avenue Alliance, Open Alliance, Ethernet Alliance, and et cetera. So certainly happy to touch on specifics as we go through here. I do want to give a high-level update on some of the TSN activities we have ongoing and SPE activities. Certainly, please refer to our presentation from December. That recording's available. That goes a little bit more in depth on some of our single-pair Ethernet activities than we'll touch on in this update. We'll have a little bit longer update on an activity we have around digital factory work. And then we'll also have a session on timing security, brief mention of some of our security TLB work with 1588, and a little bit longer discussion of some of our early work with the network time security effort through NTP. And then we'll kick it over to some Q&A. So certainly feel free as you have questions to punch them into the Q&A box, and we'd be happy to address them and have a dialogue in the later half of this. So I've briefly introduced myself and some of my background around Ethernet. I've been with the lab for something approaching 3 decades. And Griffin Leclerc will be joining us to speak to his NTS work, but he's also been with us since his early academic efforts at the university and is leading our network time security performance study efforts in his computer science graduate research work. So just a brief summary of some of our single pair Ethernet activities. Specifically here, I have an update on our 10BASE-T1L and advanced physical layer activity. We're quite active with the APL space and the industrial automation arena, and we are working to assist those organizations, the P&Os, ODVAs, OPC Foundation, FieldCom Group, in establishing a certification and compliance program for those PHY types, specific to the needs of the APL specification and that specific industry. So we are addressing that. We have test fixtures and tooling that is available. It's available on our website. I've got a link there so people can at least see directly some of the wares that we're making available. We also have some automation software that we'll be making available this month and through the months ahead with updates. Review. So that offering for services is launching this year. We've had it as part of our what we call the low-speed single-pair Ethernet service, and we'll be spinning out a 10BASE-T1 service specific to that focus area, likely this month. Beyond the 10BASE activities, we have several activities around 100, 1 gig, and the multi-gig efforts, the 2.5, 5, and 10 gig single-pair Ethernet activities. And that is in many forms. We continue to engage with the Open Alliance to support their test plan needs, erratas, and updates to the ISO standards that they have contributed and have launched there. We also are continuing to work with the multi-gig community to perform our initial physical layer testing for multi-gig, while we also try to coordinate with the industry to enable more detailed conformance testing around multi-gig. We are very interested to work community, be it from a 10BASE-T1L perspective or a multi-gig perspective, to try to accelerate the adoption and problem solving from a technical nature of these early products. So I do expect to see those events later this year. And it has been brought up before, so I do want to call out specifically some interests in the industry for 1000BASE-T1 Type B PHYs. These are the longer reach physical layer links out to 40 meters that increase the potential use space for those types of products. Also to note, for those who have the interest, we have already confirmed our first large Plugfests post-pandemic here with the Ethernet Alliance in the end of April for their high-speed networking activity. And that will lead right into an InfiniBand Trade Association, or IBTA, Plugfest in the beginning of May. So that will be good to see those activities resuming under our roof here in our group test period facility. Now, in December, I had a longer talk around the state of our TSN activities and how we're trying to take this beyond AVB. I've got 2 slides from that past presentation that I just want to touch upon again in case we have new attendees, as I believe we have here. One topic here is just around validating the TSN standards. These standards are many and varied. There's various shapers and various technologies that have been defined at this point. What was AVB, which was defined by 5 standards, more or less, now is a set of some 42 different IEEE standards alone, let alone profile efforts that I'll speak to next. So we have already preemption conformance test capabilities, detailed services that we can offer at 100 gig in our various groups here. We have early time-aware shaping validation, preemption, filtering, and policing validation that we can perform. I'm working with external parties that would like to see those solutions become broadly available and more publicly accessible. So I expect those publications to be this calendar year as we come forward with those test plans. But there's many, many other related areas. We're currently working with the IEEE to perform power profile certification of the IEC 61850 9-3 and the C37.238 1588 power profiles. And we have early work for the G8275.1 and .2 ITU telecom profiles that certainly, I think, have a mix of interests across various spaces, be it telecom, front haul, or such. So validating the standards is one thing, but there's so many choices as to what standard is used and how to use it and how they interact with each other, given those choices, that the need for profiles really was recognized some time ago, and there are several underway, right? So there was originally the 802.1 BA, the AVB profile, mostly for the pro audio space. And that's been around for over a decade at this point. But since then, no other profile through the IEEE process has been completed. We're past 2 years, I believe, in the IEEE 6802 industrial automation profile. We're past the 1-year mark, I believe, with the 802.1 DG effort for an automotive profile. And there's a recently started aerospace profile, and sometime slightly before that, the telecom profile. These are progressing, but they're still works in progress that will help shape down the number of options that are available. But we still have issues where the base standards need improvement, or interactions between the standards still need to be explored. As just a brief example, the Industrial Automation Group 6802 has spent at least 6 months, if not longer, performing detailed simulations and studies of the 802.1 AS technology, the GPTP variant of 1588, that from the 2011 standard updated to the 2020 standard still needs further study and simulation to really assess how large of an industrial automation network they can support. The bulk of that work is done, but just an example of the type of detailed efforts that the standards groups are pursuing while they try to move towards a ready for the industry sort of launch of the technology. So that detailed testing of the standards can be performed, can be valuable to semiconductor providers providing solutions, but as solution providers try to field systems, we really need a common profile so that devices can actually interoperate around common sets of requirements, not just driven by a particular customer demand, be it an automotive OEM or similar. I have worked with parties to define fairly tightly scoped profiles for their particular use case, and I am trying to work with them to get that in a public setting so that that can perhaps help shape either the aerospace or the automotive profiles, depending on one's viewpoint. So we will talk a little bit about the industrial automation effort that we have with the APL effort. Sort of touched on our 10-base T1L activities there and the awareness of the emerging 100-base T1L activities. It's 3 years now, I think, that we've been talking about a conformance effort for IEEE 6802, and that's still in the formative process of how that group would go forward, develop test plans, possibly and likely develop test plans that would be IEC standards to define the testing process and validation for that industrial automation profile. So that work is ongoing. I'm just going to take a quick peek at questions. And I'm glad I did. Martin, I'll try to answer this quickly, and I'll spend some more time later. Comment about the telecom profile and the networks. There is a standard, if my memory is correct, that is the 802.1 CM standard that speaks to the use of front haul. It uses, I believe, preemption and one of the ITU timing standards, and little else in TSN. And that's useful. Preemption is useful. Synchronized timing is useful. The telecom profile itself, though, DF, I believe, is focusing on a broader space. But there's a lot of work to do in all these spaces. And while I can't go deep into any one of them in the time here, what I would be happy to do is sync up with anyone offline to try to go deeper into the details. And we can also potentially sync up with some of the chairs of the various activities or editors whom we've had the pleasure of having in some cases on these calls. So I do want to touch briefly on some of our activities around the Industry 4.0 or digital factory effort that we have underway here with the IOL and some of our partner organizations. So this will take a few minutes, but I really would appreciate any feedback from the attendees or any pointers to other contacts that you're aware of within your organization or partner organizations. As I describe what is, it's a mouthful, it's the NSF, IUCRC, CDFI. In the US here, we have the National Science Foundation that helps fund some pure research activities. One of their successful efforts in the past few years has been creating centers for research that are collaborative efforts between industry and university, the IUCRC. And so we have partnered with some organizations in the pursuit of a digital factory innovations center, something that I'll explain here in these coming slides. So this is a coordinated effort between UNH and our electrical engineering department, mechanical engineering, computer science departments, as well as NC State and Georgia Tech. And we are looking to create a center for research that is engaged with the industry, pursuing needs of the industrial partners. And those topics might be around synchronization for processes, cyber-physical system interactions, artificial and machine learning, topics of that nature. So there's a few details here. Obviously, we'd love to have follow-up calls with any that have specific interests on these topics. But again, at a high level, the thrust areas for the research work are around self-aware processes, augmented AI, self-organizing systems, and from our involvement's perspective, protocols and interoperability, something where people can build systems with COTS components following agreed standards and profiles, much like the profiles I just referenced, but also higher level specifications, be it from a group like OPC Foundation or similar. So while our focus would be on that protocol and interoperability, an organization like ours, the Interoperability Lab, engages many students, and we engage many industry members that I believe we can well support the research component of the industrial interest for future needs, as well as the academic researchers' interest in helping to pioneer new spaces. And if this center can help coordinate resources between Georgia Tech, UNH, and NC State, that would be fantastic as an outcome. This will be an effort that is outside of UNH alone, because it involves all three organizations. It's outside of UNH-IOL alone, but something that by combining our resources will have, we believe, a larger, more successful research effort for this digital factory of tomorrow. So again, there's a lot of content here. I don't intend to read through each component, but we have experts in the field from Georgia Tech, NC State, and from UNH that can help bring their research efforts together in a coordinated fashion if it aligns with industry need. And how the IUCRC effort works is exactly that. It's not an academics lead effort, it's an industry-led effort of what a need is, what the project should be, what the desired outcomes are that the researchers can support. So it's a successful program in other technical spaces that NSF has been supporting, and we look forward to the success of this particular CDFI effort as it evolves. Now, given COVID, the evolution of this has been slower than desired. And when I mentioned this in December, we had planned an industry meeting in the March timeframe. For various reasons, we've delayed that to an unspecified date in the June to September timeframe. But that still gives us some flexibility in communicating with those interested parties as to when we can best see your involvement, answer your questions, and we can do that one-on-one with interviews, if you will, of your interests, or you can participate in this planning meeting when we announce the final date. That will probably be held at Georgia Tech, but the final location and date is not settled. Following that, once we have commitment and interest from a sufficient volume of industry, then we would finalize our proposal with the NSF, expect to see that awarded as we have all positive indications, as long as we get the particular level of interest that is demanded by the NSF program. And then we would expect to see that launched next year, given these various delays that COVID has unfortunately imparted on us all. So again, I'm not going to read through all the different details here, but you can see at UNH, we bring the expertise of our computer science and electrical engineering and mechanical engineering departments together, as well as our John Olson Advanced Manufacturing Center, our Interoperability Laboratory, and connectivity research efforts that coordinate between our EE and ME and IOL activities. NC State brings in various labs for high performance computing and data analytics, and Georgia Tech has their various efforts around factory information or advanced manufacturing facilities that really bring different aspects of expertise together in what we hope will be a unique and beneficial process. And to be clear, the NSF IUCRC effort is not limited to the initial parties. This is a process that, if successful, if other industry members are aware of sites at other universities, or if other universities wish to participate, they're welcome to join once the center is created and proceeding forward. So the NSF also has a very strict set of rules of how these efforts are organized and how organizations, how industry members participate. So details of that I'll spare us here. But again, if this strikes an interest where industrial automation and the use of TSN or wireless technologies and AI and ML become of interest to you or parties you're aware of, please feel free to reach out and let us know so that we can schedule some interview calls and follow up with where your interests might align with the early efforts of the CDFI activity. Moving on, we have for several years now been working with the IEEE Standards Association, their ICAP effort, the Conformity Assessment Program, to launch a 1588 certification. And that power profile certification effort is finally close to bearing fruit. We've had a number of devices in pilot testing through this pandemic. Some of those ordinary clocks are coming to completion here very shortly. The test suite specification is in discussion within the IEEE committee and eventually going for ballot and approval. That should be, if not the end of this quarter, early the next quarter. And then that program should be finally launched. the program is continuing to expand. Boundary clocks, transparent clocks are going to be covered by the test suite, but we still are looking for pilot participants to finish the validation there. And once that's complete, there's still a desire to potentially expand, whether we expand to the ever ongoing updates to profiles like the power profiles. C37-238 has ongoing updates, as does 61850. We may expand scope to look at things like PRP, HSR, or with the IEEE and sufficient interest, we may expand to look at other 1588 profiles that would benefit from validation efforts, be that 8275.1 or .2 or some other direction. That's the type of feedback we'd be looking for, how we can assist. Briefly, I mentioned in December that we were working to join the ORAM Alliance, and that finally has happened as of the end of last month. So we look forward to participating directly with ORAM and engaging where we best can, leveraging our capabilities, be it around our 1588 efforts, our V6 efforts, or just our general know-how on running Plugfests and hosting testbeds. So Martin, to your question about telecom profiles, there's the standards and the profiles that are being written there. And then there's the industry efforts like ORAM to try to bring some tangible benefits to the telecom operators through Plugfests and shared knowledge of best practices, if you will. So certainly we look forward to our TSN activities, verifying the conformance aspects, but activities with the ORAM Alliance to at least facilitate some of that activity. OCP tip and TAP efforts like that are also of interest to us, depending on where we can get enough interest from the industry. In addition to the TSN activities, obviously time, 1588, as I was just describing, has been around for a while, but the validation of those protocols is important. So is the security of that timing transport protocol. So as many may be aware, the 1588 standard in 2019 updated and provided a more useful security TLB in that definition. And in support of that ongoing draft, we had a graduate student complete their thesis performing an implementation of that in PTPD. That's open source. We can provide information on how to get access to that. But it's only an implementation of the security TLB. And if you're familiar with the 1588 mechanisms, it doesn't define a key exchange mechanism, right? If you have exchange keys, if you have that mechanism, what the security TLB would provide you is some ability to detect tampering with the timing information that might be conveyed to you. Time itself is not a secret, so it's a little bit of a different problem than what you might have with TLS or such. But you still want to make sure that the information hasn't been tampered with, that you can authenticate its source. So to that end, we have had the benefit of some support from the industry. And at this point, if you are able to speak, Griffin, I will turn it over to Griffin Leclerc to speak to some of his ongoing NTS activities.
Absolutely. Hello, everyone. I'm here today to talk about what Bob just discussed, which is the proposed key exchange mechanism and security TLV, essentially, in NTS over NTP. Thanks to a generous gift from the Internet Society, I, as one of the graduate researchers pursuing this effort, has been given very generous funding to kind of develop a three-pronged effort, which I'll get to in a moment, to develop a performance study to show the different discrepancies between NTS's performance versus base NTP without any of the security mechanisms, and develop a conformance interoperability suite. Again, as Bob discussed earlier, the 1588 security TLV lacks the key exchange mechanism, and it is highly likely that 1588's security update will contain a key exchange mechanism that is identical to, or at least very similar to, NTS's key exchange. And again, the Interoperability Lab is working very closely with ISPCS, the Symposium on Precision Clock Synchronization, supporting their Plugfest activities and having supported one of their events in 2013. So to getting more into the nitty-gritty of NTS, the diagram on the left is an adaptation of a diagram found in the RFC. This is just the very high level how the key exchange works and how subsequent secure timing transactions work afterwards. So we have our client in the lower part of the diagram, which initiates an interaction between the key establishment server after which there is two sort of actions: a response to the client that contains a cookie, the cookie contains a number of, or an amount of information regarding here's how the server you should contact, here's the encryption mechanisms for verifying the timing information from that time server. And the second part of the response is internal to the timing network, where the key establishment server communicates to any number of NTS-aware NTP servers that says, here's that client's information, here's how you decrypt a cookie from that client. So the servers, in this case, server N, will receive a request from that client that says, here's my secure cookie. And statelessly, server N will reference that lookup table and decrypt the cookie, allowing the encryption of, again, a sort of TLV on the end of the NTP frame, sending it back to the client. And as Bob alluded to earlier, the timing information isn't secret. So the timing information could be tampered with, but that TLV, that sort of encrypted information at the end of the frame, allows for the verification of the information from the server. So any attacks could be recognized and mitigated. And again, the overall point of this mechanism is to ensure that time originates from a trusted source. It doesn't ensure that the information you receive is accurate, but it allows for that insurance on your own part. So if we can move on to the next slide. In order to verify that time originates from an entrusted source, the Interoperability Lab has begun that three-pronged effort I discussed earlier. The development of a protocol performance test plan, where through various means of network emulation, we will evaluate the authenticity of existing network time security implementations from the industry and ensure their conformance to the RFC. We have an interoperability test plan, where instead of those emulated environments and conformance directly to the RFC, we ensure that multiple implementations of network time security interoperate with each other in a more practical environment to say, here's how it would actually work in industry, regardless of how they fare against the strictures of the RFC. And finally, the performance and scalability study, which is designed to showcase any discrepancies between NTS over NTP, the amount of time it takes to encrypt the traffic, the potential timing impact. And I believe I have a bit more information on the next slide regarding the study. Yes, so looking into the study more in depth, we've located an open source NTS implementation of Cloudflare's design written in Rust, and we are going to augment that with a number of software packages under the umbrella of Cargo Bench, which is the benchmarking framework most used by Rust, or most available in Rust. We're going to separate the NTS operation from the NTP operation as a sort of kind of control to say that here's how the protocol performs with NTP only, with none of the security enabled, with none of the key exchange, with the TLVs absent, and then compare that to how NTS operates, where you have all those mechanisms in place to show a number of discrepancies. And using that augmented implementation, we're going to deploy it to say, here are a number of practical results where here's how your system would perform using only NTP compared to here's how it would perform using our implementation, or in this case, Cloudflare's implementation of NTS, and any potential resource improvements that are necessary from that. So moving on, if you go to the next slide, please. Those specific quantifications I alluded to earlier, an additional number of CPU cycles consumed through the encryption or decryption of, on the client or server end respectively, of those TLVs, the additional memory usage of the entire system, including the addition of the key establishment server, something that isn't present in base NTP operation, and any additional memory usage in the servers 1 through N in the diagram I had showed previously, and any potential impact on the timing protocol. These mechanisms take time, and that while things are being encrypted and transmitted and such, the information is not necessarily decaying, but there's a potential for inaccuracy. And finally, for this presentation on the next slide, we have a number of experimental topologies, like I alluded to earlier. This would be pretty similar to our interoperability test plan the second part of our effort, but this is specifically related to the performance study where we have a number of emulated clients to key establishment servers, to a singular key establishment server, to our singular time server in the upper left there. On the right-hand side, we have a high number of clients compared to one timing server and one key establishment server, a much more realistic depiction of how this protocol would fare. And finally, in the lower left, we have a singular client compared to the timing server over some emulated loss and delay. Again, a much more realistic specification to show any potential performance discrepancies as they would behave in the real world. I've begun this effort starting, I think last November was when we first began. And I've actually started implementing the augmentations to Cloudflare's NTS and establishing these topologies to gather measurement results, and hope to see results of the study in the near future. Thank you.
Excellent. Thank you very much, Griffin. And Griffin, I know you'll be publishing in a few locations, including for your thesis, but also I would expect we may have a paper in one form or another contributed to this year's ISPCS, whether it's virtual or physical, remains to be seen. I do want to stress an important aspect of our work with ISOC here is to try to encourage the adoption of this technology, because having a security mechanism but not having adoption and deployment due to fears of performance burdens or such doesn't help anyone. And given the tight connection between the NTP network time security mechanism here and the expected evolution of 1588's security mechanism, time-sensitive networks ultimately will benefit from this effort, where we look to provide this early validation of security mechanisms as they evolve, as TSN becomes used in ever more critical applications where the authentication and validity of the timing information becomes important to system operation. So at this time, I'd like to kick over to some basic questions of any topics. Folks on the call, if you don't have the ability to chat, please feel free to type your questions into the QA process. And I believe we've also got a poll where we're very much interested to see your feedback on what topics we can bring up in our next forum, which we would expect to be in the 2-month time period. We're trying to follow about a month after each IEEE plenary or interim. So happy to try to shape this, and feel free to contact us directly with specific feedback on topics you'd like us to get deeper into. So with that, I am not driving to mute or unmute, but if folks have a question or would like to grab the microphone, you are welcome to do so. And Martin, I know I touched on your telecom profile question and telecom networks. This is one area where I hope our involvement with ORAN will have some benefit, because as a lab, we have traditionally been working with enterprise networks and core providers, as well as recently the automotive community. And while we certainly have contact with the likes of Nokia, Ericsson, or others, and contacts with Verizon and other providers, especially through our years of broadband forum activity with the DSL spaces, it certainly is a little bit newer space for our Ethernet activities to be involved with telecom. You know, one thing historically we never really got into was Sonnet or things of that form, but certainly as Ethernet continues to take over and TSN provides valuable benefits, not just to the backhaul, but to the front haul, I definitely think our organization can bring some benefits, whether it's assisting organizations like ORAN with Plugfests or providing more detailed technical validation. So again, the floor is to the audience. Open discussion on any topic is welcome. It doesn't have to be constrained to what we went over, but I'm happy to clarify or answer any questions that we can in the time that we have together here. And if you would like to unmute, feel free to ask for that. There's no reason you have to type. I will touch on just a few updates from December. These were posted with our updated slides. but we did have questions around the Type B 40 meter reach 1000 base T1. We did have various folks who were interested around the potential Plugfest activities. So again, any on the call, if there's a particular aspect of single pair Ethernet or TSN Plugfest that would be of interest to you, I'd love to hear from you directly. This slide, actually, I should change this because it is not March 22nd, 23rd. I'll change that before we post this. It'll be sometime in June or September for the planning committee meeting for the digital factories work. So there's many diverse interests here, whether it's telecom, industrial automation, automotive, semiconductor validation. I would invite the audience for anything we can address. And I see a question did come in. Fair question. We do have a wireless group that does work with some performance testing for Wi-Fi, and we do work with the Broadband Forum with some of their validation of Wi-Fi, and tool providers such as Octoscope with their Octobox solutions. But right at the moment, I have no immediate connection with the Wi-Fi 7 TSN activities beyond what I am loosely aware of being discussed within the confidential confines of the Avenue Alliance. So I would love to discuss with you offline if you have a specific question around that, but I'm not trying to be coy. I don't have a lot of details about what the Avenue Alliance is doing. I just am aware that there's some discussion around wireless validation in that particular user group. But again, if there's a specific area that we can work with you on, whether it's through Avenue, whether it's through ORAM, Wi-Fi Alliance, Broadband Forum, or other areas around your TSN Wi-Fi interest, I'd love to hear more on how we can engage with you on that. And a question from Martin. I know you can't grab the microphone, so the 5G space is challenging. The wired front haul side of 5G is an area I think we can quickly assist with, and I look forward to how we can continue to grow in that space to be of assistance. And we have a past relationship with Silicon Time and Silicon Labs, and certainly a long relationship with Microchip. So companies you mentioned in your question, happy to try to engage with those parties as we engage with ORAN now that we're formally and finally officially members to participate through that. But this type of discussion, whether it's the Wi-Fi 7 reference or ORAN, I would love to have that feedback from the parties here on where you think we should go next, how we can be of assistance, how we can help you, and if there's any questions we can clarify. Or if you just have views that you'd like to air and see what others on the call have to feel about it. You'll notice I also threw on the question of timing security and quality of time testing. There's a lot of focus on protocol compliance to GPTP or 1588. But at the end of the day, if the protocol is compliant, but you're still a bad source of time, it doesn't matter if the information is conveyed to you securely or not. That would be a problem, right? So there are areas of improvement that I think can be performed. I'm aware of some conformance testing that does not necessarily confirm that the clock identifying itself as a particular clock class is actually qualified to identify itself that way. An area such as that is one area of improvement I'd like to see the industry pursue and adopt. Quality of time being its own particular challenge to assess. I think a few folks unmuted, or maybe they don't have audio working. I'm not sure. If you're having audio problems and you're trying to talk, I haven't heard anyone, but feel free to chat or drop a question in the QA.
Hey, Bob, this is Abe. Do you hear me?
Yes, I hear you, Abe. Yep.
Yeah, this is Abe from Stellantis. This is an interesting subject that so far we are trying to push security on GBTB. I'm not sure of the specs, the IEEE specs, or even the RSR specs are up to date. That was a challenge too. I watched the presentation from your colleague, but is that the NTS one of the, is that the only option we have for securing GBTB, or we have other option on layer 2?
Within the ADA 2 standards at the moment, there's no adopted key exchange mechanism that I'm aware of. There is the NTS effort that IETF adopted for NTP, and that was led by Karen O'Donoghue. If those who follow IETF activities and TikTok are aware of her long history there. She is also the lead of the security effort in the 1588 committee, and she led the security TLV establishment that is in the 2019 standard, and she continues to work with that committee to move in the direction of adoption of something like NTS. Again, I don't know what the future standard will be, how unchanged it'll be, but for today, for a timing PTP specific security mechanism, I'm not aware of a standard-based one that I could point you to. I believe you are aware of, I do not recall the 802.1 standard. It might be AD, but I might have it wrong. That is for a device authentication, so a device ID security mechanism, but that's not about timing security. That's just for example, in an automotive use case, if you want to authenticate that a device connected to the network is allowed to be connected to the network. But the timing transport itself, let me be clear. The 1588-2019 standard does define a security TLV, which does allow you to use that defined standard with that TLV to authenticate and validate that the timing information conveyed to a slave device is from the source you expect it to be. The thing it lacks is the key exchange mechanism. So if you statically configure keys, which probably has problems in itself if you want a rotating key scheme, it would work out of the box as a standard. No profile, to my awareness, points to that security TLV today. It may in the future. Certainly, it's defined in the standard. So 1588 profiles, including GPTP, could reference that in the future. If you have a follow-up or another question, please feel free.
I have two questions. The second question is, we are trying to push to use MaxSec as an option for layer 2, and that includes probably GBTB. I'm not, I don't know, I don't have enough knowledge to know if that we can apply MaxSec for GBTB. Is that something?
I didn't list MaxSec simply because my awareness of MaxSec is such that the latency through that solution might be a problem, but I don't think it's precluded. But again, the use of MaxSec with PTP is perhaps something that I, at least off the top of my head, would not have a comfortable answer for you on the call. If others have a thought, please feel free. Eric, I don't know if you have a comment on this or a new question.
Yeah, pretty much. I was going to comment there, and since I'm not the expert, I'm Eric Parra here, Technical Engineering. We got Dr. Lars Völker in our team who was presenting MaxSec at the latest IEEE SA Ethernet and IP at Automotive end of last year here in Munich, Germany. And actually, I wanted to ask in this direction because I'm not as deeply technically involved as he is, because I would have an impression that if we have automotive MaxSec, and my understanding is today that the 5 vendors have hardware accelerators on the MaxSec enabled PHY, that the expectation in my case would be GPTP should be also covered either, maybe if not in encryption, but at least in authentication. Then I would want to ask the first question to you, Bob, whether it would be necessary at all to consider the security TLVs, because MaxSec, given that the latencies would not be a problem anymore thanks to hardware acceleration, could cover the security aspect of the timing. That would be my first actual question to you, since I'm not that deeply involved. And the second part of this is that one of the biggest issue we have seen at MaxSec with technical engineering is the establishment of keys initially, because that takes a very long time. And we have indeed presented in that IEEE last year round about 20 millisecond key exchange called MKA that Abe, if you're interested, or anybody, you can talk about that later. And
Yes,
it would be interesting, Bob, as well, to consider Plugfests of MaxSec at some point in the future. Because we talked about
that's a great
Plugfests
point. And
so, yeah, that would be my comment on this.
That is a welcome point, and we are certainly aware of MaxSec. We've had in the distant past MaxSec testing. It's fallen out of interest, so our updating of our testing services has resultingly stalled out a little bit. But there are very successful implementations in the industry. I don't mean to imply otherwise. And yes, you're right. It's the full pipe is secured, and at least on the link, and what happens within some switches can be debated. To your point about its deployment and why I was hesitant about suggesting it, I think a profile, whether it comes through AUTOSAR or Open Alliance or some other activity with IEEE that defines end-to-end use of hardware acceleration, that becomes viable. But we would want to have that security mechanism in hardware acceleration. That's somewhat a given at this point. But I still think there may be some concerns on asymmetric delays. And I'll stop there because I don't consider myself a MaxSec deep expert either. But I do know that some in the past have raised concerns with any form of security involving timing, that if there's asymmetry in the encryption and decryption path, then you're creating asymmetry that skews your path delay estimations and therefore skews your timing delivery, depending on how sensitive you are to that. If we're not talking sub-microsecond resolution, it very likely is a don't care today. But that's only my estimation. A Plugfest would be a perfect venue for that. And I'd love to collaborate with, be it Stellantis or Technica or others on trying to organize such a thing, and perhaps also with the 1588 committee or others in IEEE. If I missed any part of those questions, please feel free to grab the microphone again, but I hope I hit those.
No, thank you. I think you went through the parts at least that were on my radar, and yeah, we stay in touch for that.
Yeah, please do. Please do. I appreciate that. And again, we're looking for these touch bases to hopefully be an efficient use of the attendees' time, try to bring up topics. We all work in a lot of different related areas, so we can't all be everywhere. But if this helps communicate across some boundaries, perhaps in the coming weeks or months, I might get a chance to finally catch up with AUTOSAR a little bit. But I can't do everything myself either. So where we can collaborate and share ideas, bring resources together, whether it's presentations at the IEEE IP and Ethernet Tech Days, as you mentioned, Eric, that's a great venue for presentations. ISPCS timing specific ones is another great venue for the broader timing community. But certainly anywhere where we can share information and improve practices, I would welcome that. We do have time for a few more questions. If any have them, please feel free to raise them. Otherwise, I will just touch on the fact that I do want this to be an ongoing thing. I want it to be effective. So any feedback you can give us, I would welcome. And again, I don't have the contact information. If they're still on the call and you feel like reaching out to us privately around the Wi-Fi TSN question, I'd love to hear from you, because we have had a long history with performing different aspects of wireless test as well. My background is heavily Ethernet, but I can certainly engage with those in the industry that I'm aware of, or some of our team here at the lab who work with Broadband Forum and Wi-Fi testing in general, to perhaps even have them present at a future meeting. And also to that note, please feel free to give us feedback on what else you'd like to hear. I believe we took that poll, but if there's specifics that we didn't touch on, I know there might be some requests for further details on telecom profile activities, but yes, I'd love to get into feedback and specifics in the next call. I don't want to touch on the same topic every single time. There's so much to talk about. I think we can rotate around a little bit and look forward to that feedback. But we do have 4 minutes. That could probably be half a question if I was to answer it the way I normally answer a question, but I promise I could answer one more question in the time we have. least try to answer. So I'll just throw out the question, the strong leader naturally for the request for topics on the next forum from the poll was more on TSN, but again, TSN has many spaces. If anyone has a strong, I've heard at least from one party, telecom details would be interesting. There's the aerospace activity, there's automotive, which certainly we have some automotive interest here. Is there, and I heard a Wi-Fi question, again, can't do everything, but if there's a specific aspect of TSN, perhaps there's an aspect of one of the new shapers or some other aspect of the CNC or industrial automation efforts with 6802 that folks would like to hear more about. Otherwise, I will do my best to try to collate the information we gather from you and speak with you with updates, both on what's going on within IEEE and to my awareness, at least within the industry, in about 2 months' time. Since I see Mr. Donahue on the line, Mr. Donahue, do you have a question? I'll call on you directly.
Hi, Bob. Yeah, thank you for calling me out directly. I don't have, excuse me, I don't have a question at this time. This was very informative. My role at Rohde and Schwartz is more physical layer based, not so much in the 802.1 TSN space. So this was kind of a learning experience for myself. But definitely looking forward to hearing what the University of New Hampshire IOL has coming up in automotive and industrial single pair Ethernet engagements for sure.
Sure. And let me just touch on 2 quick ones for you if you have any immediate feedback. 10BASE-T1S is still of an interest for me. I'd love to see that interest grow from the industry and find a way to support that. I know it has potential for use cases beyond just automotive, and naturally the physical layer of that point-to-point and multi-drop technology has some challenges. But also the long reach, 1000BASE-T1 Type B ports, and even 1000BASE-T in general. While I can't get into the details, we'll probably be working with the Open Alliance on some improvements to our physical layer validation of those 1000BASE-T1 parts for reasons that should help the industry and eventually lead to feedback in the IEEE. So again, these engagements, whether it's from media, cabling, physical layer validation, coding, auto negotiation validation, all the way up to build full systems and run performance studies of protocols like NTS, are areas that our laboratory can assist with. And if I'm not an expert on it, MaxTest, for example, I literally had a call with Rambus end of last year, and they certainly are one of the leaders, if not the leader, in the MaxTest space. So we certainly are happy to try to coordinate expertise and bring best solutions together. So again, as always, I welcome questions. I appreciate your time. Feel free to contact us offline. And if you have the opportunity to join us again in about 2 months, feel free. We'll try to set that time once we can get a look at calendars and other industry activities in that time frame. But it's the top of the hour. I thank you for your attention, and I wish you all a good day.
Thank you again, everyone.
Thank you.